in section 4.5, we're going to talk about complements, which we've already hit on a little bit, and conditional probability. Okay, so complements, we've talked a little bit. Remember, it's kind of the opposite of everything if you're talking about the complement of something. So we're going to talk about what at least one. So at least one means one or more. Okay, if someone says, I'll give you at least one cookie, that means they could give you one cookie or they could give you 5 cookies. You know, they're giving you one or more. Now, the complement of at least one is none. Okay? So, if we want to write out some complements. So, the first problem says, if event A is at least one of the 6 pens works, and we want to describe the complement. Well, the complement of at least one is none. So the complement here would be none of the 6 pens work. Okay, and we can also kind of go the other way. If event A is none of the students fail the class, the complement of event A would be at least one student failed the class. So we'll use complements quite a bit to find the probability of at least one of something happening, because we can actually just take the complement of none. So a reminder from section 4.2, the first section of chapter 4, is that if we want the probability of the complement of A, since A and the complement of A have to add up to the whole sample space, the probability of the complement of A is 1 minus the probability of A. Okay, so what this means for our at least one is that the probability of at least one is going to be equal to 1 minus the probability of none. Okay, so our first question here, where we're going to use this, says 4 students are each to choose a number from 1 to 3. So they're going to randomly choose a number. We want to know the probability that at least one student chose a 3. So the at least one is the complement of 1. So this will be equal to 1 minus the probability of no student chose 3. Okay, so if we want to find the probability that no student chose 3, this is the same as saying the first student didn't choose 3. So that would mean they chose 1 or 2, so that'd be 2 out of 3. And the second student didn't choose 3. So again, that would be 2 out of 3. And the third student didn't choose 3. And 2 out of 3. Okay, and since this is an and thing, we use the multiplication rule. So here we get 8 over 27. So if we want the probability that at least one student chose 3, we would take 1 minus 8 over 27. Which gives us 19 over 27. Okay. The next question says we have 10 cards. So we're only looking at these 10 cards. 6 of them are spades and 4 are hearts. Okay. So we're randomly going to choose 3 cards. So the first thing asks, what's the probability that all 3 are spades? So the probability the first one's spades would be 6 out of 10. Okay, we're going to assume we're not putting them back. So then the probability of choosing the second one would be 5 out of 10. Sorry, 5 out of 9. And the probability of choosing the third one would be 4 out of 8. So this is the same as 120 over 720, which if we reduce is 1 out of 6. Now, to actually do a complement problem, the next part says, what's the probability that at least one of the 3 cards is a heart? Now, at least one is going to be 1 minus the probability that none are hearts. Now here, we've only got 2 possibilities in our deck. We've only got hearts and spades. So if none of them are hearts, this would be the same as 1 minus the probability that they're all spades, which coincidentally enough we just found. So this would be 1 minus 1/6, getting ahead of myself. So our final answer is 5/6. Okay, so that's using complements. And so we'll use complements when we want to find the probability of at least one of something. Okay, now we also want to talk about conditional probability. And a conditional probability of an event is a probability obtained with additional information that some other event has already occurred. Okay, so for example, we might be drawing out of a deck of cards, and we might know that all of the red cards have been taken out or something. So we just know something else about the sample space, or that something is definitely happening. So this is the notation we use. So this is called the probability of B given A. Okay, and the formula is that it's the probability of A and B divided by, so you might see this as a fraction, the probability of A. So you might see this as the probability of A and B divided by the probability of A. Okay, and often we'll be given a table like this. And so this table, it says a survey of community college students reveals the following information regarding the gender and majors of students. So we have female and male students, and then we have different majors. They could be in accounting, business administration, nursing, or engineering. And then we've got some totals already added for us. Okay, so it says if a student is selected at random, find the probability that the student is a nursing major. So this isn't conditional. It's just we want to know what's the probability that it's a nursing major. So here we're going to take the total nursing majors, which is 11,227, and we're going to divide that by the total students we looked at, 43,300. Okay, the next part says find the probability that the student is an engineering major and a female. So here we only want the engineering majors who are females. So we would look at this box and we'd see that there are 6,288 that are female and engineering, okay, out of our total 43,300. Okay. The next problem says find the probability that the student is male given the student is a nursing major. So this given tells us that we're really only going to focus on the nursing major. So here, if we use our formula, we would want the probability of nursing and male divided by the probability of nursing. So the probability that they're nursing and male is going to come from this box. So we'd have 3697 over the total 43,300. Okay, and we already found the probability that they're a nursing major. So remember, when you're dividing fractions, you would multiply by the reciprocal. So here we get our probability, is 3,697 over 11,227. Okay, and so another way to see this is we took the male nursing majors over the total number of nursing majors. So part D says find the probability that the student is a female given the student is a business administration. So we're going to look at the total business administration. Since that's the given, that's going to be our denominator. Okay, and then we want female given that, so we're just going to look at the female business administration. So our final probability is 5,795 over the 10,925.